All right. Hello, everyone. We are going to start, so welcome. We are very happy to have this session during the public day. We have 5 companies who are going to introduce themselves. You will be able to ask your question if you have some. And then after that, there will be a cocktail just behind you, so free food. So let's start with the first speech with Tom from TEDMED. Tom, please join us on stage.
Thank you. We do we have the clicker tool? Yeah, thanks. So, hello, I'm Tom. I am the founder and CEO of TEDMED. We're a deep tech startup based in Paris here also. And what we do is basically we're all about these lattice structures. It's about making things light and strong. And the best example of that is actually it's the Eiffel Tower, a famous lattice structure, and we believe that more things should be lattice structures. However, this is well understood in science because you can make things lighter, you can make materials programmable, but it is very hard to manufacture them efficiently. And that's really a problem because it's waste, and that's the mission of our company. So what we want to do is to create rational lattices that don't have to be 3D printed or don't have to be manually assembled. And that's an enormous market opportunity, as you can see, especially in aviation and defense. Here are some examples. So, for instance, this is a car part that is turned into a lattice. This is it. This is almost done. This is a space launcher part, a payload adapter that we can turn into a lattice. And for instance, this is very exciting. We did that with the CNES, the French Space Agency, and it allows us to not only make a 60% lighter payload adapter, but it also filters vibrations from the launch so that the satellite can also be lighter. And when we do this, the machine tool chain uses substantially less material and energy than in comparison to machining or 3D printing. So it's really exciting what we're onto. So as a company, we basically do 2 things. The most important thing is we have the manufacturing process. But then we have the challenge of making industrial companies work with this manufacturing process. So we also need designers. And that means that we have design software plugins for Fusion, for ANSYS, to actually simulate and design these tools. So when you look at the manufacturing part, it's called adaptive spatial lattice manufacturing. This is our patented technology. We use standard robots, which are abundantly available and very cheap. We use machine vision, and we use fiber lasers to basically make any possible connections of rods together. So we can make any shape of lattice. You can see here how this also compares with competing technologies. And then we have LDS, the Lattice Design Suite, which is all about designing and simulating so that there's rational lattices. And here's an example. So this one has also been designed by LDS and produced by ASLM. And it's very light and it's very strong. So essentially, it's an example of what you can do. Actually, if you have these opportunities, there's a lot of science that suddenly gets unlocked. So beyond strength to weight ratio, we can do all sorts of things that are already very, very well understood in academia, but are now unlocked for actually use in vehicle applications. So if you see where this comes from, we see a natural evolution from topology optimization to 3D printing to adaptive spatial lattice manufacturing, which is the future of the way lattices should be made. A little bit about the business side of the company. So we've done POCs with some very big brands. And as you can see, we're represented in a lot of verticals. So aerospace and defense, but also automotive. And that makes us quite diverse. A little bit about the team. So we have a team of 15 people now, which is mostly PhDs in material science and lattice design, and some experienced operators. And to close it up, I'll show you a bit what this looks like. So this is our team. This is what our office looks like. You see, all the furniture is also our lattice structure. this is what an ASLM machine looks like when it builds when it can build very large aerospace parts. Another picture of the lab. This is actually the building where this lab is located. So pretty famous if you're French. And yeah, we won some awards recently. This is the award ceremony of the Automobile Club de France, which actually shows also how much recognized we are in this field. That was it. Thank you for your attention.
Thanks a lot, Tom. Are there any questions, maybe? Right.
I have a question. Do you have manufacturing from the Netherlands? So you're from the Netherlands, right? Or you're all based in Paris?
I am Dutch. We have 3 more Dutch people in our company. Our industrialization partner, which you saw here building these machines, is in the Netherlands, but our base is in Paris. But I don't rule out that we might end up having an office there, yeah.
Okay. Thank you.
Any other question? Well, in case you have more questions, then there will be the networking after. So thank you very much, Tom.
Thanks for your attention.
All right. We are going to move on with Morgan from Delta Vision.
So guys, who wants to earn money, live in a really nice city between lakes and mountains, and most importantly, shape the future of space exploration and space operation? Okay guys, so I think this presentation is for you. My name is Morgan Yassimao. I'm the Vice President of Strategy and Business Development at Delta Vision, which is a really cool company based in Munich. For the moment. What do we do at Delta Vision? We fuel space mobility. We are experts in designing and producing propellant control components like these ones. So valves, pressure regulator, electric pumps, rotors, for several applications for liquid propulsion systems, for launchers, satellites, and other orbital vehicles. This one is an example of our valves. This one was designed actually to go on the International Space Agency. So those products are very difficult to make, really complex. And we are actually really few on the market to do them, to produce them. And the market is craving for them. With all of the mega constellations, the launchers, that are popping up in the new space industry, the market is really craving for them, which makes us very successful. We were founded 3 years ago, completely bootstrapped, and basically we reached, we completely bootstrapped to 50 employees now. We are 54 this month. Generated 4 million euro of revenue this year. We have more than 30 clients globally. Basically, if you go to the space center a little bit further, all the companies doing launchers, satellites, and orbital vehicles, we are working with them. And very well, really rare for startups, we are already profitable in less than 3 years. Again, because this market is craving for those products. And obviously, we have a lot of those products already in space. But this is just the beginning of the story. The big adventure lies just ahead of us. Based on this knowledge on propellant control, we are developing technology for fluid transfer, orbital fluid transfer, in order to enable orbital refueling technologies. And orbital refueling will be a game changer for the whole space industry. It's going to change completely the way we design, we think about space operation and exploration. Be it for several use cases like high mobility, reusability, sustainability, and mission extension. And of course, very strong defense use case. For that, we are supported by the European Space Agency. No later than 2 days ago, we've been awarded by the European Space Agency on a program that we are going to lead for orbital refueling together. I mean, we are leading the program and we are working on that with Airbus and OHB. And we are part of the NATO Diana Accelerator. Enough talking, we made a small video for you to illustrate what we are doing. So, as I say, we are rapidly expanding. We are currently based in Munich, but we are also opening this month a factory in Bordeaux, and by the end of the year in the US. I thought I had only 3 minutes, so no time to go through the list. But guys, if you recognize yourself here in one of those roles, we are looking for a wide array of engineering profiles and business support profiles. From junior to senior, very experimented people. So please engage with us. We have a stand here. You can come anytime today or during the networking session if you are interested in one of those positions. Be it, as I said earlier, in a very nice city of Munich, or in Bordeaux, or you are planning the future with us and moving to the US. If you want to know more about Delta Vision or the current open position, you have a QR code here that will drive you to our career page. But again, the best is to engage with us directly so you can see how cool the team is and the spirit of our startup, which is very, very special. And yeah, I hope you join us for this ambitious mission. Thank you very much.
Thanks a lot, Morgan. Are there any questions in the audience? Was it all crystal clear? Yeah?
Yes.
Hello. Is the refueling method are you the first ones who created this refueling method, or there are other companies that are doing
There are
this?
other companies doing this in different regions, in the US, also in Europe. The European Space Agency already tried, actually, but this is very complex. This is a very, very complex technology that needs to do this. So far, no one is mastering it. We believe that because of our long experience in fluid propellant, actually, we can do that. We have the right people to do this. And most importantly, some other companies we could consider a competition, like in the US, for example, they are already thinking of full service, like refueling service, petrol station in space, basically, which is what we want to do. But the market is not there yet. We need to build the market together with all of our partners. What we want to do is enable the market with a sequential approach. This is why in the video you've seen we have several steps of the demonstrator. So we have a roadmap that will unlock little by little with our partner the market. And this, I think, makes a really big difference compared to the people trying to already create a service where the market is not already existing.
Okay.
It's like building highways where the cars are not even conceived, something like this.
Where are you sending your first refueling orbital mission?
Where you mean which orbit or?
Which planet? Which
Ah,
system?
right now, so we are targeting low orbit LEO for the moment. It's just to actually try in a cryogenic, high pressure environment, and yeah, the first step actually will be quite simple. We are going to build like a Kiste in German. It's like a beer a beer carrier. It's the size actually of a suitcase, and where we have basically 2 bottles and a coupler that will connect on a very short distance, like 8 to 10 millimeters, and then you will do this fluid transfer. This is the first objective, to demonstrate the coupler, and this can be done, I think, so the mission still need to be fine-tuned for launch of May 2026, but I think this is planned for LEO. Yeah.
Any other question, remarks? All right. Well, thanks a lot, Morgan.
Thank you.
Now we are. Thanks. We're moving on with Pierre. Pierre from Neofuel. Thanks.
Hello.
Yep. Pierre, the floor is yours.
Thank you. Yes, good morning and welcome to the new aviators. So it's really important today when we talk about aviation, we all have in mind decarbonization. So imagine that we can decarbonize general aviation, I mean small aircraft from 2 to 9 passengers. Not tomorrow, not in 1 year, not in 2 years, but now, okay? So this is what we do with Neofuel, and I will introduce the project and why we need the new generation to help us doing that. So I think you all heard about, and we can see some of these behind, this new generation aircraft that use electric energy, hydrogen, and those kind of new energy. But there are some limitations. So fully electric powered aircraft can only do shorter flights. So it does not work when you want to fly 4 or 5 hours. And so you can actually maybe use turbines with diesel or jet fuel, you know. So this also is a possibility for new propulsion. But the key would be to be able to manage all this different energy to come to the best, let's say, versatile solution that helps to manage both range and reduction in emissions. So at the same time, there is a threat on a large number of legacy aircraft that are now working with reciprocating engines and that need lead to fly. Okay, the lead will be banned in 2031, leaving all these aircraft on the ground. It will be impossible to fly. So by introducing biofuels, Neofuel will fill the gap between those legacy and new aviation with a quick and secured 70% reduction of CO2 emissions. So this is huge. Oh, I don't know where the pointer is. Okay. So there are three paths I mentioned before. So the new propulsion systems, electric, hydrogen, hybrid. So those are innovative, but they are not ready yet, and it will take time to develop, certify, and make them reach the level of safety that is required to fly. There is a new approach in the US that is trying to replace the lead that is needed for the reciprocating engines, but it's not available yet. It's going to be more expensive, and most important, it's based on fossil fuel, so does not reduce at all the emissions. So the solutions that we propose to modify the legacy engines with fuel injection, in fact, replacing the old system with fuel injection and fuel ignition, is a very pragmatic and readily usable solution to, in fact, use already existing fuels also that are these biofuels, in fact, bioethanol that you can find at the gas station. So Neofuel designs and certifies engines modification kits that are including electronic ignition to replace electromechanic, one that is fitted on those engines right today. So this is already decreasing the fuel burn with better ignition. Then in 2028 we will have electronic ignition. So it's a retrofit that will allow to use different types of fuel, but all from the road fuels. And in 2029, 9 biofuel, that is the ultimate goal. And if we are able to do that, the fuel reduction will be at, like I said, 75%. So the key here is the certification of this system and the safety, in fact, safety analysis. So we need engineers, we need people interested in engine combustion, in electronic. So this is really very, let's say, interesting and concrete project. So with this 75% reduction of the non-electric energy, if we go to hybridation, we will reach 85% of CO2 reduction emission. And for this engine certification, yeah, we need this, let's say, to invest energy and also money, of course, in the project for a market that is very large and that will increase. And this is the future for aviation. So if you are interested, you can, of course, talk with us later. Thank you.
Thanks a lot, Pierre. Again, same question that I have for you. Do you have any question? Yeah?
Hello. So I want to ask about your background. Are you the founder of Neofuel?
I'm a co-founder, yeah.
Okay. And do you come from an engineering background or?
Yes, I'm aerospace engineer.
Okay.
And also airline pilot, and also entrepreneur. I had another company before.
Okay. Thank you.
Don't be shy. You can also ask your question in French if you prefer. Otherwise, yeah.
Okay, thank you.
Thank you very much. So unfortunately, Maxence from Space Dreams and Michel from Flying Robots are not available because the French president is supposed to be on the Paris show, at the Paris show. So they won't be available right now, but don't hesitate to join them in the Paris Space Hub, at least for Maxence. And now let's enjoy the networking buffet just behind you. Thanks a lot, everyone.